So floor is yours.
All right, okay. Hey everybody, I'm Laura. A lot of the work I'm gonna be talking about here was done with my students, Nagme Fazi. Um, she unfortunately can't travel outside the US, so I hope you had a chance to meet her last SIGIR. If not, kind of like, maybe send her an email saying, well, I heard about all your great work. And just like say hi to her. I think it's like these can be very isolating moments, so I always think that's a good moment to do that. All right, so I'm mostly going to talk about Rubric, which was like work I received the Best Paper Award at SIGIR last year, which is interesting because so that was actually a resource paper that I got the Best Paper Award for. There was like a research paper that was combined, which then got rejected. It got into ICTIR, however. It's like we have like three papers that are kind of like the resource paper. We have the research paper about pencils down, and then we have another workshop paper, Exam Plus Plus, where we talk about different variations of the same thing in more detail. And I hope that at the end I still have a little bit of time to talk about some of the more current work I've been doing with Charlie Clark and other people about when you can or cannot use LLM evaluations and dangers that you should be keeping in mind and maybe being prepared against. All right. Mostly, I kind of started this line of work probably like 8, 9 years ago when retrieve and read systems were a thing in NLP. And I was like, we should just in AI, we should do the same thing. And that ultimately is like a retrieval augmented generation system. That's like what I had in mind. The reason why I never got working on it is because the first problem I like to solve is to have a good way of evaluating. Like, how can you measure progress if you cannot evaluate it? Which kind of led me down the rabbit hole into like the land of evaluation metrics where I never wanted to be in. But I'm here because, well, I'm a machine learner. We need to optimize for something, and it would be good if that something actually is correlated with what humans want. So the system we find ourselves in RAG systems is that we have a system we are trying to develop. This is my RAG system. There will be some queries. There might be a corpus that's either limited or it can be the open web, whatever you have. And then here we have a retrieve and generate system. So sitting in the middle that produces output. Let's say here, maybe the query was write an essay on Darwin's theory, and then here's the output text. Right? I mean, you can do that with ChatGPT. You can do this with any other system. There are many ways of coming up with a system like this. I'm not going to talk about how you're supposed to write the system. I'm talking about how do you actually evaluate it? How do you know that whatever comes out here is actually good? Okay. What I'm going to do is I'm going to have an evaluation system which might have some machine learning component under the hood. In the first work that we wrote in 2021, we just had a question answering system here. Now I think we're living in the world where we will do question answering with an LLM. So it will be like some LLM part of this evaluation system. But there will be some inputs that will be coming from a human. Like ultimately, you want to make sure that the output is relevant for a human. Okay, so there needs to be some kind of human inputs that says, well, for me as a human, this is relevant, this is not relevant, right? It's different than maybe retrieving for a robot. There might be kind of like different needs. So you want to make sure that the system that's designed for humans actually helps humans. And this is where there will be some kind of like human input into the evaluation system, which is information that this system doesn't get to see. I call it sort of like a secret of the human. And at the end of this evaluation system, there will be like some kind of like an evaluation score, right? And this will be a score that should measure the quality of these system outputs with some kind of like process and human inputs. Okay. Traditionally, like a track maybe 6 years ago, this here wouldn't be a generate system. It would just be a retrieve system. So you can imagine crossing this here out. This here would not be an article, but would maybe be like a ranking of different articles. And this here would be not a grading rubric, but it would be like relevance labels or relevance judgments. And this here would maybe be like an NDCG score. So that's just sort of like a generalization to the world of retrieval augmented generation. All right. So I hope this is like all kind of clear. As I said before, if I say anything that is where you have a question, you're not quite certain you understand it, or if I use a term that you don't know, please just like open your mic and just say something. All right. A very popular way nowadays to do this kind of evaluation system over here is to just ask an LLM. For example, this is like a prompt that we came up in Dagstuhl in, I think it was January 2023, and ChatGPT had just broken. They say, well, we can just like say, hey, indicate if the particular passage is relevant for the given question or query. Respond with yes or no. And here's our prompt. Right. So that's kind of like very point blank. You just like outsource. You don't need any more humans anymore. You just like ask an LLM, is this relevant or not? Right. Here's an example. Maybe the query is, when did rock and roll begin? It's a deep learning 2020 topic. And here's a passage from the deep learning 2020 corpus. And it talks about that rock and roll era began around 1950s. Clearly something relevant. And the LLM actually indeed says, yeah, the answer is yes, that is relevant. Okay, question for you, what could possibly go wrong here? You know, open your mic, shout in. No idea? Nega, what do you think?
I mean, it can't be always right. So we have to see how it does in other pair of passages and queries.
Okay, so
Or
you
if
say like,
one,
well, where we just like see, well, how often does it agree with a human? Okay, so we have
what
to
if,
see.
or like maybe the information gets updated.
Mhm.
Um, like something we might think it's correct at some point and then it's get updated later on. The
Mhm.
judge needs to get updated.
Any other suggestions from the audience of what might possibly go wrong here?
The answer will not be yes and no always. Maybe
Oh,
something else.
okay. Okay, the LLM might just not follow the instruction and says maybe we don't know how to do it, or it says 0.5. Okay. You have a lot of experience with Llama, I can tell that, okay. Any other issue?
Relevance shouldn't be binary, right? So it can be somewhat relevant, but um, not entirely relevant.
So we could like do like a graded relevance, okay? Like on a
Like
scale.
maybe a part of it is correct, but a part of it is not correct.
Hmm. I mean, it could be that the LLM is just lying to us. I mean, in some ways, like Nega says, I check it with a human, and if it doesn't agree, then maybe I assume the LLM either wasn't very good or was just lying, outright lying to me. Maybe you can find this out, right? But like, it might always be that maybe the LLM is not lying on a certain part of the data, but then it just start blatantly lying at us. Unlike other queries, like we just when we think, oh yeah, we can't trust it, it might actually start lying to us, and we wouldn't know, right? So that's kind of like it's a whole bunch of sort of like things to be a little bit less suspicious of, especially in like 2025, right? All right. So part of what we've been trying to do with this rubric system, and also like with work earlier, is how can I, especially in the era of generated information, know when something is relevant. So the problem with like generated information is that, you know, I can have a human that checks one answer and I can have a human that checks another answer. But then when I press the button on my system again, I might get a slightly different answer, and I just don't know whether that actually is relevant or not. Is that still like one of the other answers that were checked by a human or not? Like we don't know. Like every single word that we add might potentially change the meaning and might change relevance, right? So that's the problem with like generative systems in general, right? I mean, the NLP community was messing around with Rouge and Blur and Meteor and so on for years, knowing that this metric is clearly problematic, but they just don't have anything better. So we just do it anyways, right? So nowadays we might just use an LLM and maybe get some more reliable answers. Who knows? What we are trying to do with rubric and exam and the whole line of work is to try to break down the notion of relevance into smaller components, something smaller that is like more fact checkable, rather than answering the big question of, is this passage or document or report relevant? We just like try to break it down into like smaller things. Like you are relevant if you're answering this and you're answering that, and you talk about this point, you talk about that point, if you do all of those things, the more of those you answer, the more relevant the answer is, right? Just like trying to break it into, I call it a grading rubric. This is like if you're a professor and you have to grade homeworks, it's kind of like it's a pretty good way to like make sure that also like no bias is creeping in. So just like hold yourself responsible. So we kind of do the same thing with this evaluation system when we use an LLM, and having a human that says, that not just says, is this relevant? We're not asking the LLM is this relevant or not, but asking a human, what does it actually mean for the answer to be relevant? Okay, in terms of like Darwin's voyage, there may be certain points that you might at some point maybe talk about tortoises, you might talk about islands, you might talk about like evolution pieces and so on, right? So you can, like, if you have an answer that claims it talks about Darwin's voyage and it doesn't mention any of those things, maybe you would say, well, that probably wasn't a good answer. It was at least like missing some pieces of information. So with rubric, we're kind of trying to design sort of test banks, or I call them grading rubrics, which I think ultimately should be done manually. I think that's where human input into the evaluation system should be entered at the very least. Where then, and I think that's kind of like completely doable. I had in the person I wrote the 2021 paper with, David Sander, he actually sat down and for some topics created his own grading rubric. I said, give yourself a budget of 1 hour to do something, to write down grading rubrics, and then run your evaluation system that sort of like uses sort of like automatic grading. And he, with just 1 hour, could essentially reproduce very nearly the system ranking that was produced by 6 track annotators that were working for 2 hours each, for 2 weeks each, 2 weeks full time. So that was kind of like a much different like cost distribution, like creating one of these grading rubrics, a lot less work than painfully going through all the different responses and checking and like saying, is this relevant or is this not? And it turns out that the more specific, the more linguistic you phrase your question, the more reliable I would actually think an LLM is. Like asking the LLM about the meaning of life and everything, maybe that's maybe a little bit too much to ask. But if I just say, is the height of the Eiffel Tower the following number of meters? I could probably maybe imagine LLM can do that, right? Or even if I would maybe give an answer saying, here's a question to which the answer is this, this, or that, is the answer given here one of those, right? So sort of like, it's more like a word matching, text matching. You can imagine like an NLP QA system from 10 years ago be able to do that task somewhat reasonably. All right. So that's kind of like the main part of the system, is like you have test banks and grading rubrics designed preferably by humans. Step 2, all the heavy lifting of scanning through all responses can be done automatically. And that will save a huge amount of time and burden and boredom and like being self-consistent, where like at least me, this human here, not good at. And you can then imagine to further include like more manual oversight. For example, what do I mean? Like if I have sort of like, here, this is my grading rubric, I have question 1 through 7, then here are my passages, and phase 2 will kind of like say, which of those passages answer one of those questions. We can even have grades, as pointed out, I think Marcel said it, that maybe want to have a graded saying like, how good is the answer here? But then from these like grading sheets, I might kind of have actually a human look at it and just spot when things go wrong. And that can just be things like, maybe some questions are missing on my grading rubric. Like, oh, I didn't realize that you can also use strongly connected components to solve the flood fill problem or something, right? This is like happened to me like 2 weeks ago. So you might want to add more questions in response to things going wrong, or you might realize that there's like a systematic issue with the grading system, where the grading system is just like not doing what it's supposed to do. So then maybe you need to fix your grading system, but there's like some element where a human can like oversee the process and just like spot when things go wrong, right? So after we've been doing this here for a while, feedback via the humans, we at some point might have maybe a set of grades here that we kind of like are happy with. And this is a grade per passage and per element on the grading rubric. Okay, now from that you have 2 options. You can either say, I want to derive a relevance label for a passage, and this passage is somewhat like the relevance label gets deduced somehow by the grading rubric. And that can be saying, Well, I give you the amount of points that was the best answer that you had. That's one way of doing that. I call it max. Or you can say you need to cover at least question 1, 2, and 3, and then ideally question 5, and you get a certain number of points for each. That would be some kind of like a graded aggregator or something. So whatever you think as a human is the right way to define a grading rubric for this test, you can just apply this and somewhat derive a relevance label, which then you can stick into track eval or whatever like evaluation tool you want to use, and just like use it like any other multi-level graded relevance judgment. That's option 1. And I call this rubrics curls, just because ultimately you produce a curls file that then you use as previously. Yeah, so nothing else has changed here. The other way to do it is to say, especially when you have a task where you generate a longer response. And interestingly, it's very easy to generate a short response, but it's much harder for a system to generate a long, useful response. And we might also remember the times when ChatGPT answered with just short answers, and now slowly they're getting longer and longer and more comprehensive. Well, that's because it's just not so easy to generate a longer answer, because you actually need to find out what things are the next possible thing to say. It requires a much higher level of some form of like artificial or natural intelligence. So the other thing is to assume that the whole response, if you generate a one long response, is to break the long response into paragraphs. Now each of those paragraphs gets graded, but you want to have a judgment for the whole response overall. You want to you want to judge the whole thing. But so far you only have grades for each of those parts, so that will be like one part of it. So what you might want to do is just check this way, and just see which of these passages answered which of those grading rubrics, and how overall, if I sum over all the unions of the passages in my response, how much good stuff is kind of in this response overall, right? And again, here there are like many different ways. The simplest way is to just say, the more rubric elements I cover successfully with the high cutoff, the better my overall response is. That's sort of the simplest way of doing it. But you can imagine a million other ways that might maybe give preference to like some grading rubric entries over others, where you want to have maybe certain bars set slightly differently. Can all be done. I haven't done it. Like what we've done in this work, we tried 2 things. We've kind of been taking the maximum grade this way as a Curals approach. And we've kind of like summed them all up, like taken the best grade vertically, and then kind of like used coverage here, like how many of those check marks do you cover with a minimum grade of, let's say, 4 or something. All right, that's in short the idea behind rubric, and how you can build up an evaluation metric, just where you have the division of labor between humans create the grading rubrics, and LLMs or NLP systems will just like determine the grades, and you can like turn that one into an evaluation system. All right, so that's the general idea. Let's work through a quick example. Here's a query title from track car year 3.
Laura, can I ask some questions?
Okay, sure, of course.
How do you know if your rubrics are atomic enough or not?
Atomic, you mean?
Like atomic, like is it specific enough, or should we break it down still? Like, atomic enough or not?
Right, right.
Another
I think
thing is that how do we know if LLMs are judging these rubrics better than the regular query passage pairs?
I will talk about this in a few moments.
Okay.
Like there are 2 answers. One is the more conceptual one, like how would we know? To which the answer is human supervision, like especially when you're missing elements on your rubric. So you might need to like expand your rubric from the supervision process. But then like, how do we know whether quantitatively that actually is a good idea or bad idea? I'm going to talk about this in a few slides. All right. Other questions? That's maybe good.
One more thing that I wanted to add was with Charlie, we've been working on like benchmarking different LLM-based relevance judgment. One was this, like your rubric framework. And one thing we noticed was how you aggregate over these rubrics is actually very important. Like if you get, let's say you grade each rubric on a graded level, and then if you get like max over all the judged ones or
Oh, has it?
average over all judged ones, you get very different results.
Yeah. And I think that that's like an element of it depends a little bit on what your task is, which aggregator you should be using, right? I mean, this was like us taking the max. It was like, okay, what is the simplest thing we can do here that has a chance of working? And it ended up like max was like not a bad thing, but we didn't look in detail into other aggregators, and they're certainly possible. And I know that, for example, in TrackRag, they had like different, they had like vital entries, and then they had like lesser important entries, right? So you would have like some of those rubric entries would kind of like have a higher weight than other entries, like more important to get. All right. But like, yeah, I completely agree with you that there's like, this is more like a framework, and you can try mess with it. And depending on what your task is, you might actually want to customize this idea. All right. So how does this work in real life? Like here's a track car year 3 query, which was sort of like 2-level. The idea is to write an article on the integumentary system. And we in particular gave an outline in saying one of the sections should be structure of the skin. The question is like, which passages from Wikipedia do you want to pull out and recycle to put in the section of structure of the skin on this article, the integumentary system? That's like the task in track car year 3. And what we did is, so kind of should come forward, come clean with you guys. We did this only in the exam plus work. The work that I'm going to talk about first is one where we generate these rubrics automatically. How do we generate this? We ask an LLM, hey, here's the query. What are the 10 most important things I should be mentioning? And I can talk later about what is the right way to phrase things on the rubric for things to work well. Initially, we just had like open-ended questions, right? And here's sort of like an example of that. So one of the elements of the rubric that we got out of ChatGPT was here's the first one. How does the epidermis, dermis, and hypodermis work together to provide protection, sensation, and regulation for the body, right? So the idea is like, if you can answer this question with the system response, then that is a good thing. It's an indicator that your system response is relevant. Another of those rubric entries is, can the integumentary system be compromised by diseases and conditions? And if so, how does this impact the health of the skin? Okay, it's another thing, right? These don't talk about exactly the same thing, but you want to ideally talk about both of those in a good answers. Or your third one is one on how does the skin act as a barrier against pathogens? Okay, so you might see that for each of these questions, there could be multiple different answers. They're all correct, right? So we are in this work, we have not run a question answering system. That's different work that they can also talk about. But what we have here, we just say, here's a question. And what we will be doing with the LLM when we show it like a passage like this is to say, does this passage contain an answer for, let's say, the rubric question number 1? We don't necessarily care to extract an answer and check the answer. We just ask, can you tell me how answerable is the question R1 with this passage down here? Okay, so and then let's do the quick test here. Like, is the question R1 about how the epidermis, dermis, and hypodermis work together answered in this passage? And where is it answered? And how well is it answered? Any answer? I mean, I highlighted it to make it easy for you. Nobody? Okay, so I mean, this question you could say, well, here it talks about dermis, epidermis, and the hypodermis and how they're together. It just says that the skin is made up of that. So it doesn't exactly say how it works together. So in terms of like how answerable is that question with this content, I would maybe on a scale from 0 to 5, I would maybe give it like 3 points, right? There's some element of the answer, but the answer could clearly be better. Okay, I can also imagine like here the answer was given a particular way. I could imagine another passage that would also give a 3 out of 5 answer, just using completely different words, right? So it's just like we just check for the answerability of open-ended question. How about question 2? Does it talk
But like,
about?
isn't it very subjective?
Well, I think it is subjective, but it's less subjective than, is this passage relevant for this query? I think answering, is this relevant for this query, is more subjective than answering, does this passage answer this particular question? Just because this question is sort of like more specific, and you could imagine either turning that into a tree, getting down to really the facts, right? But then I also think that there's some element of where at some point it just becomes like daunting, especially for a human that needs to write down the grading rubric. So this could be maybe a good compromise, but it could also be that maybe the questions could be broken down a little bit more. Right? Or maybe saying, number one, do you mention that this is a thing? And number two, do you explain how they work together? So you could break this further up if you wanted, right? So I think there's some kind of like there's still an element of subjectivity, but we have reduced the amount of subjectivity. And I would argue that probably even with track assessors, it might probably be better to have them check off this grading rubric manually than to just say, oh yeah, this is kind of like, this is good or not. And I think when we ran this track, I think the average track assessor took about 20 to 30 seconds to make a decision of whether this here is relevant for this query. So they had to actually read and think a little bit about it. So yeah, compromises. All right. But the question is like, in this case, maybe speed along, this question is not answered by this passage. At least not really. What is answered is like how the skin acts as a barrier, also like to some extent, like here, keeps vital fluids in and harmful bacteria out of the body, right? So there's like, again, another like maybe 4 out of 5 kind of like answer in this passage. So it's just like a means of breaking things down, and we can sort of like, again, build up this whole grading rubric with all the grades that we can get out of an LLM. What we found is like, I think we tried, most of the work was actually done with a rather simple LLM, Flanty 5 large. Mostly chose it because it was the strongest stuff I could run on my A40s. If anybody wants to donate better GPUs to poor Laura, I'm happy to run it on other models as well. But that was what we had available. And it was actually kind of like doing a relatively good job. It was also like much better potty trained than Llama, let's say. Here's another query example from Deep Learning 2020, when did rock and roll begin? And you can break this down into things like which musicians were pioneers, which major influences led to the emergence of rock and roll, and what's the general consensus of rock and roll. So I mean, and here's sort of like a passage that may answer some of this, at least partially. You could maybe say here in this case, the Boswell sisters maybe could be one of the musicians and bands considered pioneers, unless you read this text carefully and you realize that they were actually writing a swing song, not a rock and roll song. But it talks a lot about the origins. And here's maybe another point with respect to task. Whether you want to do that or not depends on whether in your task you're literally only interested in answering the question, when did rock and roll begin? To which the answer would maybe be 1950s. None of the other things matter. Or whether your task is to not just give the answer point blank, but to actually give some kind of like elaboration of the answers and tell me some more things about the beginnings of rock and roll and why was it like the 1950s and not something else. Okay, so that like, it depends. This question should determine whether you care about doing this or whether you care about something else. Mark, I see your hands up.
All right. So yeah. So where is R1, R2, and R5 coming from?
In this case, it came from ChatGPT 3.5.
So you give it the title and you're like, what are important things that you'd be like, all right. So how do you characterize these, though, with regard to the traditional narrative that a human assessor might produce to say, when they've got a query like this, a human assessor might be like, well, a relevant passage should discuss and mention an actual date or time period or event or songs or something. They would give some sort of notion of what their expectation of what is relevant. And I mean, some of these things seem a little like tangential to what a human might ever care about.
Well, these are just like 3 examples out of 10 questions. We asked ChatGPT 3.5 for just giving me the 10 most important things. And I agree with you. I think there was some work where was this from you? Where
I don't know.
where they actually took track assessors guidelines and turned each of those bullet points in the guideline into something like a rubric.
It's definitely not me. Anyway.
Well, I mean, I'm just saying it makes sense. I think for TrackCA year 3, there was no guidelines other than, well, should that be on the Wikipedia article on that topic? Yes, no.
Yeah.
that was the guidance. So it was very abstract and not very topic specific, right? But like, and as I said, like I think while in this case we use ChatGPT 3.5, I think ideally it should be done manually, right? And I can show some work where we did it manually.
Yep, great.
But we didn't have that for these open-ended questions, which ended up actually kind of correlating pretty well with what was working. Here's our grading prompt. Like this is a prompt designed for Fluenty 5 Large, where we just say, can the question be answered based on the available context? Choose one. Highly relevant, mostly relevant, partially relevant, limited relevance, minimally relevant, substantial shortcomings, not relevant at all. Question, passage. Right, that was the prompt that we used with Fluenty 5. Nagme did also like more work with similar things using Llama, Llama 3. The main problem with Llama is to actually get it to follow instructions. And we don't have the money to run it with ChatGPT 4 or 1.0 or something, but it will probably also be like a good idea. All right, here's like some concrete example. I don't know whether you can zoom in. Where we kind of had like these are the first.
Can I add something? Sorry.
Okay, sure.
With Llama, I think my experience shows that if you try Llama with umbrella prompts on like grading, it works really well. Like I tried with this prompt and umbrella prompt, so I'm just thinking like if we maybe like the prompt is has like more that reasoning aspect that it breaks down the task, Llama at least can do well.
So after this, I can talk a little bit about Nagme's method using multiple criteria, where she kind of placed best in Tau in last summer's LLM-judge competition. And she did it in a particular way, and I think she somewhat got lucky in phrasing the prompt in the way that it works really well with Llama. I think Llama is very opinionated with which words you put in the prompt and how you do that. Like, I mean, it's sort of like my students are playing through Check That Lab, and they're like, it always says the main claim is, and I can tell it 3 times to not include the main claim is, and it will now extra include the main claim is twice, right? So it's like, I mean, I call it sort of like training the LLM to not do unwanted behaviors, kind of like training a dog. You have to, umbrella is like a not very well trained dog, where other models like Fluenty 5 is very well trained to just be within the instruction. And I think lots of work with GPT went into training it to really follow the instruction and do that one above all else. But like, yeah, that's like, I think we need to, it's difficult because, Nagme said like working with any LLM, it's like hiring a new person for the team. You need to hire them, you need to onboard them, you need to understand how they work, and then you need to, then you know whether you should fire them or not. Like we occasionally said, Llama, we want to fire you. You're not part of our team anymore, just because we got so frustrated with it. Anyway, all right. So this is like an example of what my system actually did here, and you can sort of again derive sort of like relevance label for a curl, so like as a curl style from this one, or you can just like derive sort of a coverage score where if those 3 were passages that were on an article, which was like in TrackCA, the setup, then you can sort of like derive a question. Or even if you have a ranking, you can imagine you want to take the top 20 from a ranking and essentially turn that one into a longer response. How good would that response be? In other ways, so like what's your marginal relevance of the top 20 in terms of information overall? Like as in like not, we don't want where the same question is answered by every single of those 20 passages, but then many other questions are not answered. That's like not a good answer. It's like highly redundant, in not really gaining very much, even though it would have a high score according to NDCG, because, well, your top 20 all contain something relevant. So that's sort of like the difference between using a curls-based score versus using a coverage-based score. All right. This is some answers. I don't want you to look at these numbers. I'm telling you that the bold numbers are better than non-bold numbers, and gray numbers are even worse, I think. So these are like 3 data sets: Deep Learning 2020, Deep Learning 2019, and Track Year 3. What I have down here is like a whole bunch of direct grading prompts. Like there was a simplified Thomas prompt that was graded, like the 2 of the work that we did with Fagioli and a whole bunch of other people from Doug's tool. I have a Helm prompt, I have a Soon prompt, there's different with few shots, without few shots. What you see that these, I call them direct prompting method because there's these, is this relevant? Yes, no. That's all what we have down here, which seems to be working relatively well on like deep learning collections. They're pretty competitive. It kind of really stops working on Track Year 3. And I don't know whether this is maybe a test set leak with the LLMs, or whether the Track Year 3 topics are just more complex than deep learning queries, which could also be, you know, like more broader, disconnected from the passages. This is sort of like our approach using like the answerability question. Like here's an open-ended question. How answerable is it? And you can have like different cutoffs. Like we have a cutoff of 1 versus 4 versus 5. And if that is the cutoff, then that will determine is this passage relevant or not under this like curious-based method. And you see that this approach actually not just also works really well on TrackDL 2020 and 2019, but it also ends up actually working really well on Track Year 3, which is kind of like remarkable. Like it works, it kind of still keeps on working even if the topics are more complex and difficult to answer, where down here the direct methods fail. Some other fact that I want to say here that we found in the meantime is that if you have a really strong LLM, let's say Llama 370 billion, those direct grading prompts seem to be working better. Where if you only work with small LLMs, they seem to be working worse. However, those methods, like whenever you break it down, it works still very well with small LLMs. And we found that with different ways of breaking it down, like this particular one that I talked about, or breaking it into multi-criteria, or breaking into actually factoid question answering, and so on. And even like breaking it down with nuggets. We tried the same thing with nuggets. The only difference is like a change in the prompt. We say, instead of saying generate 10 questions that needs to be answered in a relevant article, we ask generate 10 key facts that should be mentioned on the answer. That's how we generate the grading rubric with nuggets. And then the grading prompt ultimately is still the same. It just uses the word key fact instead of question, and mentioning versus answering. And these 2 words kind of like make a difference. So what happens is with the nuggets that overall we see a similar trend, the answers are a little lower. And in particular, what we find is that with nuggets, it ends up being like too lenient. So you end up topping out where all the systems are kind of having a lot of like relevant things up there. So you top out against a metric of 1.0 per query, which then on average like ends up being just like not very selective and identifying the really great systems from the medium grade systems. So that's kind of like a problem that we ran into with nuggets. And I was interviewing Ellen last SIGIR and saying, Ellen, how do you make nuggets work? How do you need to phrase nuggets so that they actually are not just topping out? And she kind of essentially confirmed what we also saw here. So kind of just phrasing your nugget as a question seems to be really helping in terms of like getting more nuanced details, separating a better response from an okay response, at least in the LLM world, right? And I mean, these are currently like fully automatic evaluation metrics because you both generate the rubric with an LLM and have it answered with an LLM. We just break it down into these 2 steps where they are sort of like verifiable by a human. All right. Can it distinguish good from bad systems? Like what we have here is these are Track Year 3 systems. The black line here is the official rank score of these systems. So you see, these are the better systems. They were actually the ones using BERT. That was like, we did Track Year 3 in like 2019. It was like before pandemic, where BERT was still kind of like up here. And then there's some systems here at the end that are clearly like not very good. Bunch of BM25 stuff is kind of like down here. This blue method here, this is the method I just talked about, just with a high grade cutoff of 5. Like you need to give a perfect answer and the grading scale of 5, otherwise we count that as not relevant. And you can see that we follow the same kind of trend as the official score. The scores don't have to be the same, but the way that we use leaderboard scores is to identify what's the best, what's the second best, and so on. These are all relative scores, but you can see that we kind of like mimic the same kind of like overall shape of the rank scores that we assign. So what you can do as a metric is to do like Candel's tau. Candel's tau asks, how often would the blue thing prefer a system that of two systems, how often would the blue system prefer one system and the leaderboard prefer another system? And this here are all sorted according to official metrics. So this here would be a case where that would, we call that one a system flip, where the leaderboard said, well, this system is slightly better than this system, but like our metric just said the other way around. And Candel's tau metric ultimately counts how often do you have a system flip, also called discordant pairs, over like all pairs. That's essentially what the metric is measuring. You can also do a Spearman's rank correlation, another form that just looks at every system that's put at a rank under the official leaderboard, how many ranks did it go up or down in our metric? That's what Spearman rank's measuring. And these numbers here are all Candel's tau and Spearman's rank numbers. Right. You also can see that sometimes things do not quite work as expected. I will probably not have time to talk about this. It's in the exam ++ work. And we find that those here are outliers. And they are initially, when we did it for the first time, I thought, oh, maybe my system made a mistake. And then we repeated this with LLMs. We found the same thing. And I was like, the difference is those are two metrics that look at coverage rather than producing curl files and using track eval NDCG or something as an evaluation. So there is something to be said where these two systems here might have a better coverage over all metrics than, let's say, maybe the systems over here. But they have less of all the top 20 is like mentioned something relevant. So it's kind of interesting where you actually see the difference between a coverage-based evaluation metric and I would call it a precision-based or like curl-based evaluation metric. But I think overall, this can distinguish better from worse systems, in particular here. Those are all the better systems. These are like a whole bunch of systems that perform the same roughly. And then here we have the tail end systems that maybe you don't want to use. Okay. I started on this work thinking about information generation. Now, all of this work is done on just retrieved and ranked systems, right? So I wanted to know, well, does this actually...
Sorry, may I ask a question about the slide? So I was wondering, what does cause this huge error bars, right? There seems to be a big variance in the relative scores here. So what could be the root of that? Was it like a sampling issue with the LLMs, or what could it be?
So my hunch is that if we had used more questions on the grading rubric, it might have gone down. But I mean, this is sort of like the mean map score in this case, map score across which is sort of like an average over like all queries. And the error bar is based on changes in the map score per query, right? Now I think I think you could have probably gotten this one down, which it's just, I mean, that just means that the map score varies more across topics than others, where in the mean you still get like the same kind of behavior here. And I think if we had increased the number of questions on the grading rubric or have like more fine-grained questions, we probably could have gotten that like error bar down. Yeah, but it's a good question, worthwhile further looking at this.
Thanks.
We have some other metrics here that have like much smaller error bars. This is like here, a coverage-based score with grade 1, right? So that's like how you ask the question and which cutoff you use. Oh, the other thing is like, well, this uses a grading cutoff of 5, which means according to this prompt, you would only be relevant if number 5 was chosen, right? And only very few passages actually get the high grade of number 5. Most grades that we have observed is either 0 or 4, and 5 maybe is like awarded in maybe like 5 to 10% of the cases. So that also like introduced a whole bunch of instability. In other words, we kind of use the cutoff of 4, which seems to be like more stable. And I need to like look at this. I don't have the numbers. I don't have the numbers here, but like it's you kind of see how the error bars go down. And this is just sort of like, maybe an artifact issue of picking a grading threshold that's too high, and then you just don't have enough passages. So there might be many topics where you don't get any 5. So you kind of says like, well, this is all kind of like your methods are all bad, right? Other questions about this? Okay. So here I was wondering, okay, it works on retrieval and ranking systems, but will this metric also work on generative systems? And typically what we see when we use, let's say, a track standard for generative systems, that all the generative systems get a score of 0 because they have never fully reproduced the original answer, because you just add one additional word and the answer doesn't match anymore, right? That's the problem with like generation system. So with generation system, either you have all generative system getting a score of 0, or you can end up being more lenient, do something with Rouge, where suddenly all generation system gets a score of perfect 1, which is kind of like neither of which is particularly useful. So what we showed here is the black systems here. Those are like systems that were retrieval systems, where the purple systems, those are just like we ask GPT to produce an article, and we have like different kind of prompts. Like either we just say answer the question, or produce a web article on that topic, or produce a Wikipedia page on that topic. And what we can see is that this is of the rank of these systems here, like 3 to 27. And we find that some of these prompts are here at the top. Now we have a bunch of other systems, then we get this Wikipedia answer, and then we get some more systems, then we get another Wikipedia answer. And here at the very, like close to the end, we get like particular other prompts, right? And this is kind of like where in this kind of evaluation, what was that? That was probably MRR or something. It ended up being that giving a very short, succinct answer was kind of like the best. But what the point here is that we can compare ranking and generation systems of on equal footing, because just by taking, well, a ranking system would generate, let's say, the top 20 passages that would retrieve would be one answer. How good are those? Versus you generate an answer, how good is that answer? And while they sort of come from like different sources, we think of them as very different problems. We can at least sort of compare them on how much good information is in your system's response, no matter whether it's a ranking or it's a generation, which I thought is kind of like, it's not exactly hard evidence, but it made me happy to see that maybe we have a metric that we can actually compare different things and get some kind of information out of it. All right. Didn't we get to talk much about the other things? You can ask me about it. We have like another, I think, 9 minutes left before it's over. Is that right, Nega? I just talked about the rubric autograder workbench, which is ultimately trying to find a better evaluation paradigm for retrieval, generation, and anything sort of in between. The main goal here is to have a system where there's sort of a clear pathway to integrate a human into the evaluation without just like short of asking a human to verify a black box label, which is just really hard to say for a human. But instead to have a way that's maybe more natural for a human to say what is relevant, either by coming up with a grading rubric after inspecting a few answers, or by like looking at whether there's like any answers that are like missed by like scanning through the results like post hoc. Maybe like adding more grading rubrics, making sure that the grading actually kind of like works and is like in alignment without having to do the whole heavy lifting just purely manually. But so having sort of like a halfway in between. So between the one extreme here of just doing everything just manual, no support, and just saying, hey, LLM, is this relevant versus not? We wanted like some approach that sort of is somewhere in between, some middle ground, something where we can include a human in a way that somewhat like seems natural and believable, but then also where we don't have to do all the heavy lifting ourselves. And also like where we have grading rubrics that are reusable for when I develop the next system in preparation for a new submission, I still can maybe reuse the grading rubric, even though I might not be able to reuse like the relevance judgments in a generative system. So this was the point here. And I can talk more about different ways of asking questions. I can talk about like other dangers that we've seen over the years, or like just like where we should be cautious. Yeah, just asking about it.
I have a question that like how do you see the rubrics that are generated from like the question itself, like here, is different from the rubrics or like nuggets that are generated from like auto nuggetizer where they generate from the document, like the source is
Yeah.
document dependent rather than just the question dependent.
Right.
How
No,
did
they were
you
just generated out of thin air. We said, ChatGPT, here's a query. What should I answer to meet that query? Right. And there are sort of good things and bad things. I know that in Auto Nuggetizer, they start with the query and a particular passage to generate nuggets from it. So one of the problems, I mean, there's a practical challenge with this approach is that you get a lot of nuggets, of which many of them are very redundant. So there's sort of like you need to then curb down the redundancy if you do that. You know, ask an LM twice, you get 3 answers, right? Another concern that I would have is like ultimately I was trying to come up with an evaluation system that is easily reusable and it's not biased. Like all of the old track collection is somewhat biased to the nature of the systems that were submitted at a time that were judged. Like we found this out when we started working with the sequential dependence model when I was in Bruce Kraft's group, and we used benchmarks that were not judged on SDMs, and it was very hard to show that there's an improvement. Where once you move to a benchmark where an SDM was like part of it, you can now see, oh, SDM is like the best method, whatever, because humans probably submitted all kinds of different variations which were like judged. So there's like a danger of like biasing a benchmark with the pool that you submit, the method that add to the pool. And we were like actually interested in a method that is less dependent on the pool, where kind of is maybe also like less important for writing your next SIGIR paper to submit a system to the pool that then gets like judged the same way, which might be the case if you build a grading rubric only based on what was submitted. You might be missing things. Just because they weren't submitted at the time doesn't mean that they were not relevant. So in some ways we did it a different way. I looked at it and said, yep, we could have also have done that. We didn't. I think that's just that you might end up with you have to make slightly different trade-offs if you generate your rubric just out of thin air versus by looking at concrete examples. I think for a human, it might be important to read some answers to actually come up with a reasonable grading rubric, because I think maybe we are lacking imagination. And LLM is in some ways like better at this. Yeah, but good questions. Next question, please.
So I think that coming up with these rubrics is kind of like interpreting the actual information need, what's behind the query in a way, right?
Yes, that's exactly it. Yeah.
So wouldn't it be better for whoever had this conversation to specify the rubrics that it should have covered? Because like right now, as I see it, is I'm having an information need without actually be interested in any specific aspect, but in like everything that comes along with this information need, right? Which is probably rarely the case when I use the information access system, right?
Yeah, I mean, honestly, when I was working on the track car year 3 topics, I picked topics that I have a personal interest in, because I said, well, if something happens with NIST and I end up being the one that has to do all the judgments, I better want these topics to be somewhat interested to me. I don't want it to be about soccer because I do not care about soccer. So, but I agree with you that ultimately a user needs to say what actually makes a good response to them, which can sometimes be personal, even though maybe in IR, especially the machine learning, as a machine learner in IR, I think there should be a general answer that is a good answer to give to most people, right? But then, I mean, there's a lot of interesting work with, personas of like saying, well, if I'm a vegan and I'm allergic to soy and I'm asking for certain food related topics, I need different answers than maybe somebody who's really into eating meat and no allergies, right?
Yeah,
So
that was exactly what I was hinting at, because I think that is an excellent measure for measuring personalized information access in a way, because I can pick these rubrics because I know what I'm looking for, right? And then I get probably a very accurate measure if the system answered that satisfyingly according to my personal information need in my head.
Yeah.
since I'm co-organizing ICAT this year, I'm very interested in this. This could be a good way of integrating this in the evaluation process.
Yeah, I mean, if you want to talk about this in detail, I'm happy to do so anytime. Yeah, I'm also like working with the nuclear organizers, so maybe we can have a shared code base there.
Yeah, awesome.
I have two more questions.
So can I ask yeah. Okay, one quick question. So I don't know if I missed how many numbers of rubrics are being generated per query, and if you only provided the topic, only the query and not the narrative behind it for generating the queries.
Yeah, so in this particular experiment, we asked ChatGPT 3.5 to generate 10 questions that should be answered on those topics. Like the answer is 10 per topic. In track car year 3, there's like, the super topic and the subtopic. We asked for 10 per subtopic, which means like the documentary system has like several sections. Each of those like super/subtopic was treated as one query, which is sort of in line with how track car year 3 was kind of like, it was a little bit more complex, but like it's somewhat, it seemed to be useful at the time. And also kind of like led to definitely better grading rubrics. I feel I was not answering some of your question. Was there anything?
The second one is about the description that is usually present in track topics.
We didn't use the description here. Also, like track year 3 did not have any descriptions, other than like very generic. Like the use case is to generate a Wikipedia article on a topic, but that wasn't a topic specific description. I think there was like some work that used, as I said, like track annotator guidelines to do something like a rubric, and yeah, or maybe like elements of the description. I don't quite know. But like it's clearly, I mean, this is more like a when we did this, we were kind of like ahead of everybody else by a few weeks. So that was sort of like what could we try that's a reasonable first experiment, but like clearly like more work is like warranted. Nigga, I think I'm out of time.
Yeah, if there is any...
I have so many slides left. I don't know what to do now. Well, I'm giving another talk in 9 hours. At this point, 8 hours. I can talk about the other slides in the next talk.
Yeah, sure. Thank you so much, Laura, and everyone for showing up. It was very interesting, and I think it was one of the most interactive talks we had so far. Thanks so much.
Sure. And Niga, hold on, before you close the meeting, let me grab the link that you shared. All right, thanks.